Hello and Assalamualaikum. My name is Sharifah Fatihah binti Syed Azme, IT Metric, AA17029, course name Bachelor in Civil Engineering, Faculty, College of Engineering. My supervisor is Dr. Sharifah Maszura binti Syed Mohsin. Today, I would like to present my final year project, which is a study on oleochemical such as partial sand replacement for sand bridge. First and foremost, I would like to present my content of presentation, including introduction, problem statement, aim and objective, scope of study, significance of study, literature review, methodology, material selection, result and discussion, conclusion, recommendation, and also references. For the introduction, I would like to brief the brick, which are one of the materials used in the construction of houses, buildings, trains, bridges, and others. Brick contain many different types in terms of color, shapes, quality, and strength according to the material used. In this research, sand cement bricks are used to produce new brick using the material provided. As I, as I already mentioned in my title before, I will study on oleochemical sludge as partial sand replacement for sand brick. So, oleochemical is the waste that come from process of palm tree derived from this fat and oils and usually contained in shampoo, soaps, and others. The popularity of oleochemical product is increasing, particularly due product due to the fact that the raw material of this industry is from renewable sources. Due to the property, they produce a lot of oleochemical sludge that I use for my research to replace material in my brick production, which is sand. Sand is natural resources and important substance that is used in manufacture of bricks. The function of sand to provide bulk and strength to construction material. Then this research will be explained about the replacement for this sand. This photo show here photo of sand brick and oleochemical before and after being ground. Now I would like to proceed to the next slide, which is problem statement. First problem statement is the price of manufacturing bricks increased due to the shortage of natural sand in Malaysia. The high demand from the current society make country more developed in terms of development by construct more building in the future so that brick seller or supplier will increase the price of the brick itself if the supply of sand, natural sand, to produce more brick was limited. Next problem statement is environmental issue, which is related to the sand mining. Okay. Sand mining cause to destruction of environment. So environment problems occur when the rate of extraction of sand material exceed the rate at which natural processes generate this material. In oleochemical industry, the process waste need to be treated before discharge, even the material considered to be environment friendly. When the waste from factory release, it will be thrown and placed at the landfill. So to avoid landfill pool with the waste, it can be used for a better solution in construction industry. Then I would like to proceed with the next slide, which is objective. Uh, the overall aim of the research is to investigate the performance of the oleochemical sludge in brick production when the waste replace the sand during manufacturing of brick and its potential to produce the quality brick using the waste material of oleochemical. So here is the specific objective of the present work are to study compressive strain test and flexural strain test of oleochemical sludge as sand replacement with partial replacement by volume 0%, 5%, 10%, 50%, and 20%. Second objective is to determine the water absorption test of oleochemical sludge as sand replacement with partial replacement by volume 0%, 5%, 10%, 15%, and also 20%. Next is the scope of the study, including the sample of sludge that taken from FPG oleochemical industry at Gebang, Pahang. The compressive strength test that have 3 samples that needs to test on 7 days and 3 for the test on the day of 28. Each of the sample must have partial replacement by volume. Next is the flexural strain test also have 3 samples that need to be tested on 7 days and 3 samples for test on the 28th day. Each of the sample must have 5 partial replacement by volume, as mentioned before. Then for last test is water absorption test. Only need to be tested on day 28, which means 3 samples needed for this test. Each of the sample must have 5 partial replacement by volume also. Overall tests that need to be conducted are 75 times samples. The size of the mold follow JKR standard 2014, which is 113 millimeter, times 225 millimeter, and times 75 millimeter. All the tests will be conducted at laboratory of University of Pahang. The time taken to finish all the tests take 3 months. The test will be started on the next on my last semester of 4th year. Then the material that need to the test for the test is including cement, oleochemical sludge, water, and also sand. Now I'll talk about the significance of study. For significance of study, it may prevent from getting the environment pollution due to the effect of the waste. As mentioned before, the effect of the waste, the effect of flush may not be good to the environment. So that this research would like to decrease the effect to the environment. Second is the price of brick will be lower than usual. So it will give benefits for the consumer and user also to the society. This ought to be a pivotal step in development of construction industry to be more advanced. Now I will proceed to the literature review from author Kitsurin that say develop a new approach in making brick from 100 limited fly ash. Okay, the fly ash developed in the study show superior mechanical strength, especially compressive strength, compared with red fire clay brick, facing brick, and other type of fly ash bricks. For the second literature review, which is from Alta Zhang Liang, the considerable reasons are related to the strategies for creating brick from waste material, which is the potential contamination from the waste material utilize the absence of pertinent guidelines and the moderate acknowledgement of waste material based by the brick industry. Uh, Next is from Puma that saying the replace of the natural fine aggregate which is sand partially with the coal bottom ash by a different percentage that including 10%, 20%, 30%, 40%, and 50%. From this literature review, it showed the successfully through the experiment conducted in this journal. This is the methodology which start with the mixing of sand, pouring mixing in the mold, curing, removing the mold, the oleochemical sludge will be testing for a three tests which include uh, compressive strength test, flexural strength test, and also water absorption test. Uh, Next is, uh, as we can see from this slide, this is the photo that show the flow of the work during preparation of the sample of brick. First and foremost, we can see uh, the process of sift sand from unwanted things. Next is grinding the sludge so that it can be same as the sand size. Then mixing material using the mixer. Next is casting into the mold prepared. Before pouring the mixing into the mold, we must to apply oil to each surface of the mold so that the mixture does not stick to the mold. Then curing for the days 7 and 28 days. After that, we can start testing. Um, Now we will proceed to the material selection, which is including oleochemical sludge. This is oleochemical sludge before grinding, and we have oleochemical sludge after grind, sand, cement, water, and also including the super plasticizer into the mixing. SP super plasticizer use uh, for about 0.7. What the cement ratio use is 0.5, and the ratio of cement sand is 1 to 6. Now we will go to the important part, which is result and discussion. First is compressive strength test. Based on the slide, we can see the three sample which we taken for each percentage. From this slide, this is for 0 percentage replacement for day 7 day and also 28 day. We also take the average for of each three sample, which is um, Now we can see the control result for different testing day. It showed the increasing pattern when the more day taken, such as at 7 day, uh, I get 7.638 megapascal, and in day 28, 8.449 um, megapascal. For it showed this the same mixed design in different day taken, increasing in strength. Now, uh, the chart, uh, the graph in this slide with the same day, but different mixed design, which is 5%, 10%, 15%, and also 20%. But there's no value for except for 0%, which is control value. Okay, for the try and error was conducting um, using 10% replacement until the mixed design acceptable and proceed with another percentage. For 10% trial and error mixed design, it can be used for testing compressive strength tests after casting and curing, but the testing does not come up with value. So the testing of compressive strength test for 10% slash replacement was failed. Then there are also conducted for casting and curing 15% and 20%, but end up fail during the curing process. By using the same Smith's design for 5% slash replacement, the result also cannot be obtained. Um, Due to the MCO problem, the test cannot be proceeded until getting the result, especially for the target that need to pass 10% replacement. Uh, the result, uh, the 10%, the 10% acceptable process cannot be continued. For 10% pre-testing, the pit was too fragile actually, and does not have enough strength because of the oleochemical. We can see based on the uh, diagram below in the slide, the sludge too fragile, and the dry oleo it is because of the oleochemical. The dry oleochemical sludge cannot bind with other material in the mixing and complete the hydration process. Moreover, insufficient suction of water to interface bonding due to oleochemical water retention. The oleochemical uh, does not contain silica uh, like sand because of its dryness, inertness, and cannot be considerable the hardness of bricks. Uh, this is for the pleasure strength test. Uh, Same as before, for the pleasure strength test, I obtained the for the control zero replacement. There are 3 samples for 7 day and then 3 samples for 28 day, and the average will be taken. For the pleasure strength test, there are uh, provide or obtain for 10% replacement, which is the average at 28 days, uh, which is 0.423 megapascal. This for the day of 7 day, the 10% replacement cannot be taken because of the uh, cannot enter the lab due to the MCO problem. Now we proceed to the pleasure strength test chart, which we can see here. This is for the 0%. The strength, the pleasure strength increased from 7 day to the 28th day. For 7 day is 0.385 megapascal, and for the 28 days, 0.395 megapascal. This is the chart for the pleasure strength. We from 10% slash percentage, we got 0.423 megapascal in the 28 days. Uh, this is for pleasure strength test that we can see here the difference from uh, compression. We got the for the 10%. So, but pleasure strength test, when compared 0% to 10%, there are decreasing between these two percentage. So, the oleochemical replacement actually does not give the strength to the brick samples. Okay, for the pleasure strength also face the same problem as the compression test before. The try and error conducted using 10% until the mix design set, and we can proceed with the another percentage. For 10% trial and error mix design, it can be used for testing compression test after the curing. There are value provided from this trial, as we can see from slide before. Then by using the same mix design for 5% sludge replacement, the result cannot be obtained. There is also conduct for 15 and 20%, but end up fail during the curing process, as we can see from the diagram below. As I mentioned before, the breed condition is too fragile and does not have enough strength because of the oleochemical. As before explanation, the oleochemical is too dry, uh, make the brick dry and become more fragile. Next is the last testing is water absorption test. For water absorption test, there is only for 0%, 0%, and we have the original weight, dry oven, saturated water, rate, and lastly is the average. This is the process of oven dry. From the water absorption versus sludge percentage, which is 0% sludge, we get 12.591%. This for others values of percentage of oleochemical, we can see here that there's no value for other percentage replacement. It is because of the it cannot be conducted for the curing and casting process due to the failed replacement. No value are recorded for the percentage. there are only control value what for water absorption can be obtained because of the MCO problems. Now, I would like to conclude for my research presentation, which is in conclusion, based on the result from comprehensive strength test, there is only control result can be obtained and can compare to other percentage replacement, which is 5%, 15%, and 20% because no value acquired due to fail at 10% trial as target. For pleasure strength test, the test decreased when compare between control and 10% replacement, while the other percentage replacement fail during curing process. For water absorption test, there are only control results obtained due to the Malaysian government movement control order problem that did not allow a student to enter the laboratory. Testing could not be performed and objective does not achieve. The recommendation for the present work and for the future work, since slush cannot be used at 10% replacement, use a lower percentage as the try and error so that oleochemical slush can be obtained, better result and accurate finding. Second is increase the water cement ratio in brick mixture to avoid the sample easily fragile due to dry condition. For the future recommendation, the student need to manage and organize the work effectively so that the testing can be finished on time as per requirement. Add a little amount of finely powdered lime to enable binds and the particles of bricks together for resulting in strong and durable bricks. This is the references from my research. That's all from me. Thank, thank you so much for lending your ears. Thank you.